asked to factorize this quadratic. And the most typical version of this quadratic comes from when you have the plus c, but you'll notice that in this case c equals 0 because there's no number being added to the end of the equation. So in fact this is the form that we're looking at here. It's a lot easier because there's obviously a common term in these two, which is the x. So the way to tackle this one, to get it into factorized form, is to look at what they have in common and then subtract that. Well, not subtract, it's division. We divide it out and we add the brackets. We're looking for an equivalent expression. So let's have a look at this. We have x squared minus 12x. We don't, if we want to be clear, we can write a 1 there. There isn't anything that's in common in terms of the numbers there except for a 1. So probably worth going into a bit more detail of what we mean by in common. Here's term number 1 and here is term number 2. We think about them as x times x subtract 12 times x. Could also think about these as 3 times 4 times x. If you break that down, you could even go into prime factors. But the idea is that there are certain things that are multiplying both of those terms. And I'll just highlight one of them. This x and this x are multiplying both of those terms. That would be what we call a common factor. And if it is in common, it can be what they would call taken out. But what technically is called a division, we can find an expression for what we have here in factorized form. Let's get rid of everything and start from the beginning. What do these terms have in common? We first look at the numbers. As we said, there's a 1 in front of there. A 1 goes into both and that's it. So there are no number common terms. If I was to take out a 1, it's not going to have any effect. So that's not a factor that we care for. If we now look at the letters one at a time, there's only one letter in here and that's x. And you can see that there is at least one of x in both of those terms. So that is the number that is coming out, as we say. We say it's coming out because of this reason. It sort of comes outside of the bracket. And then we open a bracket. What has happened for that to be taken out but yet still stay the same? Well, as I said, if I had an x on the outside of a bracket here and I had x plus 2 inside, we would be expanding this to find out what it's equal to by multiplying the x into both terms, giving us x squared plus 2x. So this way round, which we call expanding, is multiplying. But instead, we're not expanding. We're going the other way. We're going this way, which is factorizing. So that's governed by division. And division is how we find out what is left in the bracket because it's the opposite. So how would I find out what's left in this bracket? I would take the first term and I would divide it by what I took out, which was x. Now, x squared divided by x is just x. Then I would take my second term, remember that a negative belongs to that, and I would divide that by x. So negative 12x divided by x is just negative 12. And now I have gone through every term. I've basically divided every term by what I took out. What's left in the bracket is the result of that division. If I go ahead and just test that by multiplying each term inside, I get x squared minus 12x, which is proof that what I did was correct, because if I undo that and go the other way, I'm going to get back to my question. So that's how we factorize a quadratic like this. And it's really important that we do. So when we're looking to solve it, we put it equal to 0 and we're good to go.
Okay, let's apply this method to some questions now.
We're going to look at the numbers first and we can see, oh, we do have a common factor. We can see that 10 goes into So I've got to straight away write down 10 because that's, you know, it's something less that I need in my mind. I'll probably do it a lot quicker eventually anyway. But you can see that 10 definitely goes into both of those. That's maximum because 10 is one of those numbers. And we can see that x goes into both, hopefully. You can see that we have x squared and x. You can't get x squared out of both. You can get an x out of both. So now we've gone through each number and each letter. As we say, we're only dealing with quadratics here, or at least a single term, a single letter. In the case of multiple letters, you'd go through each individual letter and compare them one at a time. Since we only have x, that's great. Now we open the bracket. This is meaning 10x has come out, come out of the bracket, but we know that that means that it's been divided out. So if you're, dividing by 10x now, there's no shame in writing it out separately, just to get a handle on what you're doing. Just make sure it's not in the way and doesn't like detract from your argument. You keep it separate as in notes. Well, how are we going to do this? Well, we've got 10s are going to cancel, and then we're going to cancel the x with the squared on top. So we're actually just left with x. It's rather good. Now, being digital, I can just get rid of that. So I'm going to be left with x. And then if I'm going to do 30x divided by 10x, well, 30 divided by 10 is 3, and it's positive, so I'm going to write positive 3, and the x divided with x is going to cancel. So I'm left with this. So there's the answer to the first one. We have factorized, meaning we've added brackets. You can go and solve that by putting it equal to 0. We're not going to do that today. Or at least you could watch the video later where we do it, and it will be today. We're not going to do it in this video, I mean. Okay, so the next question is a bit horrible in a way, but only because it is slightly more odd numbers. I can see the common factor of these two are 3. Just double check in your own mind if there's one that's bigger. The bigger the factor, the better, because if you don't choose the biggest factor, you'll have to do further factorization later. I think it is 3. Even if it's not, go with it, and you'll be ending up with a more simple expression. Probably best that you get going with it than get stuck. X goes into both. And if I think about dividing now, I've got 3 and an x, and then I divide by the 3, so I get 10. How did I decide that it was positive 10? I was doing a positive 30 divided by a positive 3. So that's going to be a positive answer. Okay, next one. Running out of space, huh? So looking at these, bit of a pain actually with the numbers. These are odd numbers. They don't have a common factor. 29 is a prime number, so it's going to be difficult. You don't need to worry about numbers. If there are no common numbers, it's fine. Just go with what there is in common. Move on to the letter. And we definitely have an x in both. So it's only an x coming out this time. And we're going to open the brackets. And what we do is divide by what we took out. So 9x squared divided by x is 9x. And then 29x divided by x is just going to leave us with 29. And it looks really weird because technically what should be in the brackets is the smallest, generally what you see. But that's fine. Now let's have a look at a different one. So we've got 9x squared plus 27x. This is where there's a lot going on. And this is where you might be tempted to write 3x, right? So this is why this example is here. Because you think, 3, that's it. Now, let's just say you did write 3x. And we'll go through again. We'll just have a look and we'll see. Really, some of you are thinking, I should have taken 9 out. Well, if you did do 3, we're going to divide it. We're going to have 3x just there. And then 27 divided by 3, which is 9. And then, okay, you think, wow, I've finished. But you're not finished if there is a factor left in that bracket, which, as you can see, there is. So you would end up having 3x, and which is already there. And then you're factorizing this bracket. Now I can see 3 goes into both of those terms. So 3 is going to come out as well. And then we're going to be left with what we should have been left with, which is x plus 3. Now all of that, it took a moment, pause it if you wish, just have a look. And this is what should have happened. Should have realized that 9 goes into both, and so does x. And you take that, and what you end up with is x plus 3. One step, saves time, just neater. And some of you probably saw that straight away anyway, so well done to you. And this is a bonus one at the end because the questions are relatively simple, so why not? The rule that we were doing here applies to higher powers as well. So if you have a cubic and you definitely have common terms, then this is the way to do it. So in this case, highlighting the fact that, well, it's asking how many x's can we get out of both sides. We saw that there was just one in the previous one, but hopefully you can see that in this last one there are 2 x's there multiplied together, and there are 3 x's there being multiplied together. So the common factor is not only a 9 from the 9 and the 27, we can actually get an x squared out of both of those terms. Which, if we now do our division, we've got just a plain old x. If we do 9x cubed divided by 9x squared, and then we've got 27x squared divided by 9x squared. Well, the x squareds cancel, and it's just 27 divided by 9, which is 3. So the rule applies upwards, and this is how you factorize this type of quadratic.